Good day, guys. Welcome back to my channel, RHC Engineering. And today I will show you how to check the shear of the beam using the simplified formula as per the ACI 310M-11 equals 11.2.11. Okay, kung hindi ka pa subscribe sa channel natin, please subscribe and also like for the every videos that I uploaded in this channel. And without further ado, let's get started. Okay, so we have here the material properties. We need to import and input the data, the compressive strength of the concrete, also the Fy, the shear reinforcement yield strength, the Phi of course, which is the reduction factor of the shear strength, the Lm, if using the normal weight concrete, so you just use one. Then of course the section properties, P is the section width, the H is the section height, this is the full height of the beam, the C is the cover to center of the steel bar sets. Assuming same concrete cover from the compression and tension part. Then of course we have the section effective depth. So the formula of this depth is we just deduct the concrete cover from the total height of the beam. And also we have here the applied forces, the ultimate shear force, VU in kilonewton. Then we need to uh, input also the reinforcement that we had provided in our design, in our details, the spacing between the stirrups, the number of legs, and the diameter that we have used in the beam. Okay, so for example, in the F prime C, we inputted the data of 20.1. This is the common concrete mix in the Philippines. And also the Fy, let's say 275. Okay, then let's use 250 by 400. Then concrete cover 58. Yung 58 na yan, commonly when we using concrete cover of 40 plus stirrups of 10 and half of the diameter of the main bars. Let's say we use 16, so it's equivalent to 8, so that is 58. Then after we inputted the data, we have here the calculation report and the concrete shear strength for the non-porous member subject to shear and fractures only as per disclosed. The SCI 310M-11 clause 11.2.1. The VCN or the concrete shear strength is the V times VC, which is VC is equal to 0.17 times Ln times the square root of prime C times B times D. Then we need to check the section adequacy of the beam. So from this formula, the VSN max is V times the quantity of 0.66 times the square root of A times C times BD. Then we need to get the Vmax, which is VCN plus VSN max. It's 238.6 kilonewton. And checking the ratio of the VU over the Vmax, it should be less than so and 1.0. So our ratio here is 0.628. So the section is adequate. Then we need to calculate the shear reinforcement. Shear reinforcement and the shear force carried by the shear reinforcement, Vs is the quantity of the difference of the Vu minus Vcn over phi. So this is equals to 134.84. Then we need to check the quantity of this one or the value of 0.33, the square root prime CBD. It's 126.5. So which is V is greater than sa quantity na to. Then Of course, we need to check the maximum spacing between the stirrups as per the requirement of the code. Just the minimum of 600 and d over 2. So this is 171 is the minimum, so d over 2. Then the is the provided spacing between the stirrups in our input data here. Let's say this is 200, then two-legged stirrup, of course. Let's use 10. Okay. Then, uh, of course, we need to provide the 200 again. This is the provided, which is in the encoded data. Then the S minimum is the used spacing between the stirrups, I mean, is the minimum that is provided, that we had provided, then of course the S max. Then whichever the minimum or whichever the lesser, that is the governing spacing of the stirrups. So 171 and 200, so we use 171. Then two-legged, I think we need to this one. Number of stirrups, okay, we need to link this one. Okay, okay. Let's check if this functioning. Okay, it's already functioning. Then, after we getting the use spacing between the stirrups here, then we need to calculate the required area of the shear reinforcement, which is Vs times S over Fy times V. Yung V's natin is the shear force carried by the shear reinforcement. You use the capacity of the shear reinforcement times the spacing that we have used over the Fy times the effective width. We have here to 86.73 m squared. Then we need to check the minimum area of shear reinforcement, the AVM minimum. Of course, the maximum of the EV minimum and the AV required. So our AV minimum is whichever the the lesser, I mean the maximum of these two equations because it is minimum. Okay, so AV minimum one is the 0.062 the square root of prime C times B times S over Fi. It's 43.21 square meter. Then the other one is the 0.35 B times S over Fi, which is 54.41 mm squared. Then we need to calculate the area of the shear enforcement, which is the maximum of the AV minimum and the AV required. Okay, so this is 286.73. Then we need to compare it to the use provided area of the shear reinforcement, which is 0.25. The one that we had provided, we need to compare to the maximum. It's, of course, this is the area of the reinforcement. 0.25 times 0.1416, or this is pi equivalent. This pi value times the n, of course, the number of stirrups or the legs, times the diameter is 235.62. So use provided area of the shear reinforcement. So when we check the ratio of the EVUs provided over the EVUs, the requirement, it is more than 1.212. So it should be, we need to increase the size of the beam, or we need to modify the reinforcement requirement. So this one, okay, we need to check this one. Let's say the default one is this one. Okay, so let's modify the color. This is 1.2, 1.2, not, okay, 1.2. So let's change this one. Is this one not okay? Okay, if it is not, this one we need to modify the color. To fill no, then font, this one. Okay. So if this laser one, let's say 0.9, it's okay. So automatically it will change. Okay. Okay, guys. So means our section is not okay as per the reinforcement we had provided. And by the way, every time we change the dimension of this section properties, the right side is also uh, updating every time we change the section properties. See, then okay, we change it to the initial value to 50 and 400. Also, we need to copy these properties. Copy for this one. Okay. Again. Then we have a summary here. So we have V over V max. Section is adequate, but uh, when we check the EV provided over the EV use, it is more than 1.0. So it means our reinforcement here that we had provided is more than the maximum capacity of the beam as per the code. So means we need to increase the size of the beam as per the capacity of the applied shear force, of the ultimate shear force. Or we need to modify the reinforcement provided. Okay. As you can see in the summary, V over V max is only 0.6286. The section is adequate. So means we need to decrease this one. So let's say two legs. So it is 1.82. Let's say 250. Oh, means we need to increase this one. Sorry. Means we need to modify it into a more reinforcement. Okay, let's say 100. So as you can see, it is already okay and the ratio is less than 1.0. Okay, so it means we need, this is the EV use. It should be the ratio of the EV use provided, which is the calculated one, over the EV use should be less than 1.0. Okay. So from this reinforcement and the beam section, our check design is okay. So let's say 200 for the VU. So our section is not okay as per the code, but the section is adequate as per the code, but the reinforcement is not. See, so means we need to modify in this area. So let's say let's use 12 mm. So it is satisfy the requirement. Okay. And mm, okay, guys, that's for today for this video. And thank you for the support to my channel and also to the members, especially the level 2 members of this channel. Okay, and that's for today. And see you in the next tutorial. Don't forget to subscribe and like also this video, share and click the notification bell so that you will be notified every time I uploaded a new video in this channel. Thank you and God bless.